All right. So if we look at here, so this right here is the National Oceanic and Atmospheric Administration's website. So this is what airplanes, space stations, this is what they use in order to keep track of the weather. So as you can see up here, what I'm scrolling right now, you can see that over the last 24 hours, there was a G4 storm that's been observed, um, S3 solar radiation storm that's been observed over the last 24 hours, and there hasn't been any radio blackouts over the last 24 hours. You can see that tomorrow for the 11th, there's a 99% chance prediction of a G4 magnetic storm that's without any other flares taking place, ladies and gentlemen. Without any other flares taking place, even though the Lord has shown us two more on the way, tomorrow is already expecting a G4 magnetic storm. G5 is the highest scale that it goes to. And so right now, what I want you guys to take a look at is currently the sun. When we change to the, when we change um, from the angstroms, okay, let me let this reload here. I'll show you guys. Let's see here. Let's see here. Four. Boom. So you guys see all those bright spots on the sun?
Mhm.
The sun currently has hot spots. These are where the flares come from. If you look at the top right, like in this area here, you can see a little flare going off there. That was the latest we have. Down at the bottom, down here, you can see the timer. So right now it goes into the 13th, and this data is usually backed off by a little bit. All of the flares come from these hot spots on the sun. And as you can see, the sun currently is hot all the way at its equator. This is not normal because usually if you just look up like sunspots, you'll see there's like one here, there's one in the middle, then two more up top. If you look over here, you can see a bright spot at the top right, at the left. Whenever you look, the sun usually does not have complete heat all the way at its equator, but that's currently what the sun has. And when we look at thematic, we can see that when we look here, the bright region is yellow. And the bright region all the way on the sun is connected from one side all the way to the other. These hotspots are not singular, but instead all connected. This takes us to our sister Helengue's vision, where she saw that the Lord is going to cause scientists to scratch their head because when they look at the sun, they're going to be confused by what they see. She saw a rip, a tear happen in the sun. When we look here, we can see the activity of the solar coronal mass ejections. As of the last 24 hours, the sun has not sent off any major coronal mass ejections, but you can see that right there, the static, the protons you see, this is from a storm hitting Earth. And so even the camera is getting hit with a lot of protons because the sun is sending out a lot of energy currently. Even in this camera, you can see all of the static. This is active protons hitting the lens. Now, here's where things get interesting. Yesterday, that big spike you see on the left, that was the solar flare that's still on its way to hit us currently. You can see we had a smaller one over here that barely touched an X class. And then this latest one, let's see here. This latest one was a strong X class flare, but the sun
Recording in progress.
But the sun is staying in this C class level for the yellow line. So the sun is still active at a C class level. Now, the X class flare, what I want you guys to pay attention to is the timing of when this happened. This happened on the 11th. This happened on the 11th, almost around 10 a.m. Universal time. This happened, I repeat, this happened on the 11th around 10 a.m. Universal time. It did not reach Earth until roughly the 12th at midnight on the 12th. So you had roughly 14 hours where the Earth was chilling in this green zone before the solar storm began. That's how long it took for the particles to leave the sun and reach the Earth. And on this chart, you can see the proton flux. As of the 11th, this chart, if we let's go to a 7-day chart, the sun didn't start behaving unusual until around the 10th. On the 10th, this is when we started to receive heightened activity, but as you can see, only on the red graph, right? So all of the protons didn't start acting funky until the 11th. This is why you see the blue graph has increased, the green graph, and the yellow graph. These different graphs represent different particle mass, meaning how powerful the particles were coming towards the Earth. The fact that we had a major spike on the red, the blue, the green, and the yellow all on the 11th goes to show that this explosion that happened from the sun sent not just slow wave particles, but also heavy massed particles towards Earth. And yet we had already crossed over the warning threshold. As you guys could see, the proton flux spiked up on the 11th, spiked up again on the 12th, took a little dive down, spiked up again closer to the end of the 12th. We've now crossed over into the 13th. Now the sun is in this stage where it has not spiked up yet, but it's still above the level of warning. And so the way the sun is behaving currently, if I can zoom out to 7-day, you can see that we had roughly back to back, day after day after day. We had explosion here, explosion here, our biggest X class explosion here, and the sun has not exploded again since here, and yet the Earth is already in G4, sometimes G5 magnetic storming. And so currently what we're heading into, based on the dreams and visions of our brothers and sisters, we should be expecting 2 more big flares, but instead of them being big flares, Halangue saw that a tear happened in the sun, and the fact that the entire equator of the sun is hot means that there could be a ripple, a flare that comes from one area and ripples all the way through the sun. And this is what can cause it to where when this explosion happens around this time, instead of it taking 14 hours to reach Earth, this explosion should be big enough to reach the Earth within 2 to 3 hours. So that's the current forecast we have on the sun. You can see that the reason this is behaving at such a level, I'm not gonna lie, guys, this has me feeling like a news anchor. This feels pretty cool. The reason this is behaving on such a level is if we look at, let's go to our tools here. We'll look at our solar wind prediction. So this right here is an upward facing view of the solar system. And so the sun is this yellow dot, the earth is this green dot here. These two charts have their graphs to the side. You have plasma density to the left, and you have radial velocity to the left on the bottom one. And you can see that with radial velocity, when it's super gray, that means it's the most powerful. And the same with plasma density. When it's super gray, that means when it's the most powerful. When we hit play, you'll see that we had that first flare come, coronal mass ejection come, and we had almost 2 hit Earth around the same time. But when you look at this lower chart here, you can see that a lot of the density is in this later third one that came. This goes to show that the flares are becoming stronger and stronger each time they react. And so the first 2 already hit Earth. Now, if I pause it, this one should be making contact with Earth around runtime that is around up top. The 12th, 18th. So this one should already start making contact with Earth based on this projection sometime around now, right? That this storm is now crossing over, hitting Earth's path. What this is doing is it's weakening the Earth's magnetic field. If we go to products and data and we look at, is it this one here? Yes. You can see in this chart here with the density, you can see how much our Earth is being hit. Oh, geez. Yeah, it's already gone. Yeah. So, boom. That right there is the magnetic field trying to protect the Earth from the blasts that are coming from the sun. But these blasts are so powerful that it's sweeping away a lot of strength that the magnetic field has and is actually weakening the magnetic field and making it exhausted. You can see that by the effects it's having on by the effects it's having not just on the atmosphere, but I'll show you guys also the effects that are happening on Earth as to why this storm that's coming will cause auroras to be seen by Martin all the way in Tanzania. So if we go to our products and data and look at, I believe magnetos. No, we just looked at magnetosphere. Here I gotta click around a bit until I see the one I'm looking for. Activity plot. Yes, right here. So the magnetic perturbations over the globe. This goes to show how much the Earth gets charged up by what happens. And this is what has happened to our Earth. The red shows the nanoteslas of how much the ground is charging. And this is our major problem. This is the Earth in its baseline before it got hit. This is what just happened to the Earth. The red will show how much of the Earth just got charged up. And so because a lot of the Earth's magnetic field has been charged up, now you have positive and negative polarity, right? Look, this is normal, and then you can see when the storm begins coming in. Right. And because the Earth is conductive, it's charged up now with a lot of particles, a lot of protons. That's going to make it to where if we get hit again, the negative charge that comes from the Earth is going to interact with the positive charge that comes in from the solar system. And so the Earth is primed now for an event of catastrophic measure. So all of these flares that have hit the Earth could potentially be just warm ups and precursors that charges up the Earth before the Lord rises the dead. And so that's currently the state that that all of the planetary, the sun, the Earth, the atmosphere, that's the current state that everything's in currently as we're coming into the 13th and the 14th.
All right.
Can I just ask a question real quick?
Yep.
Have you guys considered the speed of light and the travel? If the sun just automatically went black all of a sudden, it could be literally minutes, just like 8 minutes.
Yes.
Just throwing that out there.
All right.